This video continues my introduction of R by looking at subsetting. Subsetting is one of the most common things we do in R, and subsetting is when we go into a data structure and retrieve those pieces or elements of specifically what we want from the data structure. There are three subset operators in R: single square brackets, double square brackets, and the $sign, which is shortcut for double square brackets if we can use a character vector inside the double square brackets to reference specifically by name. So to be rigorous, I'm going to replicate here in my notebook file examples from Hadley Wickham's Advanced R, 2nd edition. Excellent textbook. The text is called Advanced R, but the examples here for subsetting are not advanced. They're foundational. So let's take a look. So I'll start here with an atomic vector, in this case loading a variable x, a numeric vector. Right, strictly speaking, that is a double precision floating point, but that is a type of numeric vector. It has length of 4, and you can see they're not in sequence. We have 2.1, 4.2, 3.3, and 5.4. That's a simple numeric vector. And the easiest thing we can do just to subset is use the single brackets to return, for example, the first element. You can see it's 2.1, or if I want the third element, let's say, I can use single brackets and the 3 will retrieve for me the 1, 2, 3 third element. And of course I can combine, right? C is short for combine. If I want the first and third elements, I subset this way and I get back a numeric vector length of 2, where it's retrieved or subsetted for me the first element and then the third element together. And if I could reverse the order, and that's the order I'll get that vector back in. Negative integers will exclude. So I can say, instead of, C1, combine 1 and 3 will retrieve those elements for me, but if I want to exclude them, I put a negative sign inside the single brackets here, and now I am excluding the first and third elements from what I get back. So I get back the second and fourth element of this numeric vector. So we can use a logical vector too. I could say, here's a logical vector, true, true, false, false, is itself a logical vector, and then I can put that within the single brackets to subset on the x vector, and you see I get back 2.1 and 4.2. That's true for the first, true for the second, false for the third and fourth, so I don't get those back, and I'm still getting back a numeric vector. So if I have named, if I've named the elements in the vector, I can use a character vector to subset. So here is y, again using replicating the same example that's in Hadley Wickham's book. Here now I've defined y, you can see, and I'll just print it out before I subset so you can see it. Here y is a numeric vector, but you see how it's named. So it has attributes that name the elements. Still numeric, but it has names or labels, if you like, for each of the elements, right? 2.1 is still the first element in that numeric vector, but it has a name, which is A, and I could even access these by going names, using the names function, and you see I get the names for that numeric vector. So that here I have a C for combine, 3 elements, these are characters, this is a character vector, and you can see with the single brackets. With this command, I am subsetting on the Y vector, but I'm using a character vector to subset by name, right? So I get back in order 5.4, which is the fourth element, 3.3 the third element, and 2.1 the first element. Okay, if we go to matrices and arrays, now I'll have, let me just clear these here. Now I'll define, again, borrowing again Hadley Wickham's example of a matrix, and I'll just print that out here in the console. So you can see 3 rows by 3 columns. We have a matrix, How would I know that, by the way? Well, it's still a numeric vector actually, but it has dimensions. And I could check that by saying attributes of A, and you'll notice its attribute, that's that the attribute is a name value pair, and a matrix has a name value pair of dimension in 2 dimensions, right? If we had more dimensions, we have an array. A 2-dimensional array is a matrix, and really it's a numeric vector, except it's got an attribute of dim for dimension, and here they are, 3 rows, 3 columns, gives me a matrix. And then in the example here, we go ahead and name the column names, A, B, and C. So now I'll print that matrix again, and you see my columns, A, B, and C, and they now have names. And as a matrix, I can use the matrix notation and write just generically, we still notice have the single brackets, but generically it's rows and then comma columns. And here's an important feature of that. When we omit or leave it blank, then we want all of the rows. So if we have a blank before the comma, we get all of the rows. If we blank after the column, we get all of the columns. So let's say I just want rows 1 to 2, colon for the separator gives me a sequence. Right here I'm getting rows 1 and 2, and if I leave this blank, or I'll put a space in there, I think it's good to put a space, I get all the columns. And you see what's returned there, rows 1 and 2, all 3 columns. This is a subset of the matrix, a matrix subsetting rather. Now here, I'm going to leave the before the comma blank. In other words, I want all the rows, and let's just say I want columns 2, colon through 3 in sequence, right? And you see, I get back a matrix, all 3 rows, but just columns 2 and 3. And because the columns are named, you notice I can also name them. So here, I'm using that same exact syntax for the matrix, single brackets, rows, and in this case, I'm using a logical vector. So really a logical vector here, true, false, true, which really says, give me the first row, not the second row. Yes, give me the third row. And then for columns, I would like the named columns, B and then A. And that's what I get back. And you'll notice I get them back in the order requested. So that original matrix, of course, had A before B, but I'm getting them back here, column B, column A. So it's a new 2x2 matrix per this subsetting. And then finally, in terms of matrix and arrays, Hadley-Wickham makes the point that single brackets simplifies to the lowest dimension. So if we take A, and notice this, what is this command, this subsetting command, single brackets? It's asking for the first row and all 3 columns. What we actually get back is a vector, because that 1 row, 1 dimension, it just gets dropped. So implicitly the parameter here is drop equals true, and that means anything that's 1-dimensional gets dropped, right? This command here really only wants back a row vector, so we don't really need the matrix. Similarly, if we use A11, what do we want here? Well, this is really a request for just an element, right? First row, first column, where do they intersect in a single element? We could, if we set drop equals true, we could get back a 1x1 matrix, but here with the 1 element, all we need is the vector, so implicitly drop equals true simplifies to a vector because we don't need the matrix. Okay, so let's go to data frames. Probably what realistically we mostly end up working with data frames and subsetting from data frames. And data frames have characteristics of both lists and matrices. Although in the previous video, as part of this introduction playlist, I reviewed my sequence and review of the data structures was we started with a list. And then we did data frames because structurally here internally, a data frame really is a list. A data frame really is a list. Understanding that makes it easier to use the subset notation here. But the data frames, therefore, they have characteristics of lists, being lists, but also of matrices. So if we subset with a single index, then the data frame behaves like a list. If we subset with two indices, it behaves like a matrix. It's actually somewhat natural as we look at it. And I'll use Hadley Whitcomb's example again here, where df is the variable. It's a data frame, you can see here. And I can take a look at it by just printing it out. Data frame looks like a matrix, but it's really a data frame. And it has 3 observations and then 3 columns, which we really want to call those variables in the context of the data frame. And you can see we did give them names. First variable here has a name of x, second has a name of y, and then z. So this point here about single index and 2 indices, here's the command. If we data frame and use single brackets, keeping in mind that they are lists, and we subset here, it's going to treat the data frame like the list that it is, right? And it's going to retrieve the first and second columns. So if I print that out, if I go down here, what am I getting back? I'm getting a data frame just of the first and second columns. And then let's see. Now here's very useful type of syntax. Now notice I'm using 2 indices, right? So this is I'm illustrating this rule here. When we just use the 1 index, the data, we are subsetting on the columns or variables. Now when we use 2, it looks very much like the matrix subsetting, and that's what it is. And right, so that first one before the comma is really a request for the rows, but here we're using logical and saying I want all the rows where that, notice here, data frame $x, where that value x is equal to 2, right? So you can see right now that that's that second row. See, this is a logical criteria. Is it equal to 2? And so it's that condition right there. So it's really a request for this row. And then comma empty here indicates all of the columns, right? So that command here, notice we get back a data frame with only 1 row, but we got all of the columns. And then in terms of selecting the columns here, because we gave them a name, right, we can use this command, single brackets. We just combine the names in a character vector. Is this a single or 2 indices? Well, it's only 1 index. So the data frame, it's acting like a list, and we're going to get back, if we go down here, 2 columns in the form of a data frame. And now the next command here has blank before the comma. So here we have 2 indices, so we're treating it like a matrix. This empty indicates all rows, and then we want these named columns x and y. So we execute that command, and what do we get? Back a data frame, all rows, just columns x and y. Okay, then now keeping in mind that the data frame as a data structure is really more like a list than a matrix. It is a list. All 3 of these are identical, and they return a vector. So we saw that $sign before. The $sign is a shorthand for this command here, which may be redolent of, may remind you of the list syntax. The data frame is a list. Here is list syntax. We use double brackets when we want to go inside the element and retrieve its value. So double brackets, and then we're naming the z, is equivalent here to just using the $sign, which we end up using in practice and is the shorthand. So data frame, $sign the z, what do we get back? We get back the contents of that column. Go back here to that third column right here, a variable. The contents are A, B, and C. And notice, because we use the double brackets, we're not getting back a list or a data frame, we're just getting the contents, which themselves are just a vector. Happens to be a factor vector here with levels, but a vector nonetheless. So, and that would be identical to going to the effort here of double brackets and naming the z. That's pulling out the elements. But so would just a 3 without the quotes, because then we're saying third column or third variable in my data frame, but I don't want it back as a data frame or a list. I want back the contents of it, and the contents of it are just a vector, right? A data frame is a list of equal length vectors, so that the third element in the list of this data frame itself really is a vector, which we get back. So all three of those are the same. And then oftentimes what we end up doing if we forget, or what I end up doing is I forget to use the double brackets and I'll use the single brackets, and we can do that, right? But what happens if we say data frame, now I just want the named z, I do get back that A, B, and C, but I'm not getting back a vector, right? What am I getting back? Well, let me check with the structure, because it sure looks like a data frame. And it's a data frame, 3 observations is 1 variable. So that's the difference there. I didn't go in and pull the elements out with double bracket. I got back the data frame. Same here. Third column of the data frame with single brackets. I'm getting back that third column, but really as a data frame, which is 3 rows, 3 observations, 1 variable. And then finally here for data frames, I like the subset. It's built into the base. It's maybe old school, but it's very explicit about what we're doing. We give subset the name of the data frame, and then here we give it the criteria for which rows. And then if we want, the third parameter here, select equals, lets us request which columns. So I think that's very natural. So here if I say subset with my data frame where y is greater than 1, that is giving me all of the rows where y is greater than 1, and I'm implicitly using all of the columns. If I wanted the same conditional on the rows, but only want that column x, then I say select equals x, and I only get column x. Okay, then I did earlier say that that drop was set to true, which is a service provided really, right, by the subsetting that simplifies the dimensionality for us. If we didn't want to do that, then we could set drop to false on our own. So if I go back here and define matrix A, right, this is a 2 by 2, 2 rows, 2 columns, 1, 2, 3, 4. And then if I just use the standard subsetting here, matrix, what am I getting? I'd like to subset from A. I'd like the first row, all of the columns. Remember, that really is a request for that row vector. R doesn't need the dimensionality of a matrix at that point, so it gives me back the vector y because drop was really set to true. Drop by true is the default. So if I go back and say drop equals false now, same thing. I get the row vector back, but I preserve the dimensionality, right? And I'm getting back that 1 row, 2 columns. And similarly here, if my data frame, if my DF has names of A and B, I can just request all of the rows, that column named A, or named A, and I just get back a vector. But if I set drop equals to false, then I get back a data frame, a column vector. Okay, then finally, for the lists, here's some imagery that I think is cute, may be helpful. Thinking about a list in terms of a train. In this case, the list is a train with 3 carriages. Each of the carriages contains a vector, right? Here's a numeric vector, length 3. Here's a character vector, length 1. And the third carriage of the train is a numeric vector, length 3. So that the point of this is to remind that if we go ahead and take that train and just subset with the single brackets, we're getting back a train, or that first carriage, as a list, we need the double brackets if we want to go into the carriage and just retrieve the elements as a vector, right? So single brackets gives us back a list, double brackets, assuming X is a list, double brackets reaches into the first carriage and returns the vector. And then here's a couple other examples. If we go single brackets 1 to 2, what we're getting back from the list is another list with 2 carriages. Here is single brackets minus 2, so we get back a list excluding the second carriage. Here is single brackets where we'd actually like the first carriage twice, so we get back a list, single brackets, with 2 carriages duplicating the first carriage, and that's the only example. So that if we go to here, X is a list, and if I print that out, right, you can see here that's a list with 3 elements. The first element is that numeric vector, so that's the first carriage of the train. Second element is a character vector, length of only 1. That's the second carriage of the train. And the third carriage of the train here is a numeric vector. So single brackets here of 1 gives us back, what do we get? We get back another train with the carriage of that first numeric vector. If we just want to go into the carriage, pull out the elements, we use double brackets, and then we get back the vector. Single brackets 1 through 2 gives us another train, another list, so to speak, of 2 elements, and single brackets minus 2 gives us back a train, 2 carriages, excluding the second carriage. And then we also have the $sign notation. So here we have the list, and now I've given a name to the third carriage in that list, such that if I use the $sign, right, we said that's equivalent. This is equivalent to X, right, double brackets, and then naming the label. So this is equivalent to double brackets, so that it's not giving me back another train or another carriage. It's reaching in to the container and giving me back here the vector that's inside the 4, 5, and 6. I said finally, but then I just forgot there's also subsetting and assignment, so that if we have X is just a numeric vector 1 to 5, then we can assign here this numeric vector into X with the subsetting notation. So here I'm saying assign 101 and 102, this numeric vector, to the first and second positions of vector X. So that if we print out X, you notice it didn't squeeze them in, it replaced the 1 and 2, those values that were first and second, with these values. And we can also use the null command. So here X is a list, 1 and 2 with names A and B, so that if I assign a null to the B, then what happens to my X? Well, I've erased that second element of the list. Okay, so in the next video, then I'll go through applications that are shown by Hadley Wickham in the book. Thank you.